So I definitely encourage you to all attend the GTUG happy hour. The GTUG is a great set of organizations that promote Google technology around the world. But more importantly, they all get together and talk about things that they love. They talk about the various technologies and how they're moving forward. And so go to the happy hour, but then also go to the next GTUG meeting and meet up with the folks and talk about the things that you like and things that you don't like that Google is doing, and we can all make the world a better place. So my name is Ryan Boyd. I'm a developer advocate at Google, and I'm here today to talk about OpenID and OAuth at Google. So I'm primarily a developer advocate on Google Apps, so you'll see a little Google Apps slant here, but in general I want to talk about how these technologies are used across Google. Actually, you can see my Twitter handle there. If you have any follow-up questions or critique, feel free to give me an @ reply on Twitter. So today we're going to talk about an overview of the different terms that are involved with OpenID and OAuth. We're going to talk about each of those protocols. Then we're going to talk about the hybrid combination of the two. And then I'm going to go through a practical example of an application that's been around for a while and show how it's evolved through these different protocols. So OpenID and OAuth and this whole space around identity and the access authorization for data is rapidly moving. Things keep on changing, and there's a lot of work going on there. So I'm not going to be diving deep into the protocols. I'm going to be showing you some of that, but not too much. What I want you to understand when you leave today is really the different protocols that exist, what the use cases are for them, and how they can apply to your application to create a better experience for your users and thus get more users. So what we're talking about. The first term we're talking about here is authentication. The idea behind authentication is determining who you are, determining the actor that's making requests. So with OpenID, this is determining who it is that's browsing the website, but in generic terms, authentication is used for other purposes as well, to identify applications and that sort of thing. And then we're talking about authorization. What can you do? So after we've determined who the actor is, we need to determine what permissions that actor has to access what resources and perform what actions. So for authentication, we're going to primarily be talking about OpenID. For authorization, we're going to be primarily talking about OAuth. If you treat these terms very strictly, they really merge together and clash in a number of places, but we'll try not to do that in this introductory presentation. So OpenID. OpenID is about federated identity. And I want to give you an example of OpenID before I actually dive into more information about the protocol. So I'm going to go over here. We're going to go over to a website that I love. It's called Tangle. How many of you have heard of Tangle? All right, just a few. I wasn't sure how popular it was outside of Silicon Valley, but basically Tangle is an online scheduling application. What it does is allows you to share your schedule with the world and allow your customers or partners to create appointments on your calendar at the times that you make available. So one of the things that Tangle does is really tries to get you into the application quite easily. So you can see here at the bottom of their sign-in page, they allow you to do the typical first name, last name, email address, and password, but they also allow you to sign in using one of your existing accounts. So I'm going to click on an icon here, and although I can't read this, I'm still going to approve it. It's basically asking me to pass my information, my name, my email address, and my Portuguese language over to this application. So I'm going to hit permit. And the application is going to log me in and immediately go into a very simple setup process. It already knows who I am. When I return to this website, as long as I log in with my Google account again, it will again know who I am securely. And that makes it a lot easier. No longer do you have to receive email confirmations, create password, deal with password resets. You can use the one account that you're used to using for a lot of different sites, or at least any site that implements OpenID. So now we're going to hop back to the presentation, and we're going to talk about the different parties involved with OpenID and federated identity. The first party we'll talk about is the user. That's like me. It's someone who's trying to log into a web application. The identity provider is the place on the web where I have my account, the place on the web that I want to validate that I am me. This is oftentimes email providers. You can create your own, but oftentimes it's email providers for most users, as you just saw in this application where I logged in with my Google account or my Gmail account. And then there's the relying party. In the demo that I just gave, the relying party was Tangle. It's a web application which wants to allow users to use their existing identity to log into their application. So here's what some of this may look like. I'm calling it federated identity here. There's a little bit of controversy with this model. In this model, we have 3 applications down the center. Those applications are Sassy Payroll, which is a fake online payroll application, which we're going to use later in the demos. TripIt, which is an online travel planning service, and Aviary, which is an image editor. Each of these applications allow me to log in via OpenID. Sassy Payroll just allows me to log in with my Google account. TripIt and Aviary, however, allow me to log in with either my Google account or my Yahoo account. Some may call this directed identity instead of federated identity because these applications are restricting what identity providers I can use to log in, rather than allowing me to use any place on the web. But in this case, there's still multiple identity providers and multiple relying parties. OpenID is a safe, faster, and easier way to log into websites. As you've heard all this terminology, you're probably not thinking it's easier, but it's easier for your users, and we're going to talk about each of these terms. This is kind of the motto that's used on the OpenID website, and here's what these different terms mean to me. Safe. Because the user is only entering their credentials in one place, they're only trained to provide their password to one site. Phishing, they're going to be much less susceptible to phishing attacks and that sort of thing because they know that they're only going to enter in their credentials at their identity provider. It's faster. The user is already often logged into their OpenID provider. In the case that I demoed, I don't remember actually whether I was logged in or not, but I'm often logged into my Gmail on a regular basis. So if I go to log into a website, I don't even have to type my password. All I have to do is tell that website it's okay to pass my identity onto the website. And easier. The user no longer needs to create and maintain a different set of credentials on a bunch of different websites. Now, in practice, most people don't actually maintain a different set of credentials. They use the same password everywhere, which gets back to the safe idea. Though there is some, there's actually our network technician here yesterday was wearing a T-shirt that said, OpenID, now you only need to steal my password once. But you may only need to steal a password once, but there are things that are being done to make those identity providers a lot more secure. Google for Google Apps recently announced what is called two-factor authorization. So it requires you to have your cell phone available and you receive a text message or an SMS message in order to log on to the website. So you provide your password plus that text message. So you're proving multiple things. You can greatly secure each of these individual identity providers a lot easier than you can secure every website that wants to rely on them. So there is a discovery challenge though. You want to determine the OpenID provider of a user. As we saw with some of the previous examples, I was just saying use Yahoo or use Google, but the initial version of OpenID was very open. And what it meant is that you could actually type in any URL here. You could basically say, my OpenID provider is at www.google.com/account/OE. Only geeks actually use this. Only geeks could remember what the URL was, and only geeks cared about this. So OpenID wasn't that popular. There wasn't much adoption. But the community embraced a different way of doing OpenID. And this is what we call the OpenID NASCAR. What this means is that the websites or the relying parties present a bunch of different logos for you. They tell you you can log in using your Google account or your Yahoo account or your Twitter account. And you click on one of these buttons and it allows you to log in. This is a much better way to interact with users, but it actually gets at a problem that OpenID was created to prevent. It basically makes it, if you don't have a popular OpenID provider, if you don't have an OpenID provider that everyone's going to include on these NASCAR badge pages, then you can't sign into the website. You have to create a new username and create a new password. So this is what I'd like the future to be, where you enter in your email address and you can log on to the site. It discovers who your provider is, and you can immediately log in. We're getting there. You may have noticed that there was a Google Apps button and a regular Google button. Google Apps actually gets partially the way there to that ideal world where you click Google Apps and you can actually type in your domain name, and there's a little bit special magic sauce here, but Google Apps will issue OpenID identities on your actual domain. So there's these two different formats of OpenIDs. We have the Google consumer accounts, which if you have a Gmail account, this is what the OpenID looks like. An OpenID identity is really just a URI. And you can see here's a URI for a Gmail account. And then for a Google Apps account, the OpenID identities are on their own domain. This makes it a lot easier if you wanted to, say, move off of Google Apps. I don't know why you'd want to, but if you did want to move off of Google Apps, you can take your OpenID identity space with you. So Google supports a number of different extensions for OpenID. We're going to talk about the hybrid extension later, as we mentioned. I'll also talk a little bit about the attribute exchange here. By default, OpenID provides just that URI. It just says this is a unique identifier that will be returned to your application every time this user logs in. So you can maintain state across the user's login. You know who the user is, but you don't know information like their name or their email address. Attribute exchange provides that information, and it makes it a lot easier to provide a good user experience for the user. So we support a number of different extensions. You can read up on them online. But the biggest point that I want to stress here with OpenID, there is that safe, faster, easier. It's not only safe, faster, and easier for users, but it's also better for web application developers. Because you don't need to deal with storing passwords, you don't need to deal with securing your stored passwords, and you can also get users into your website a lot faster. And this means in the end you'll have more users. So how is this done? Well, there's all this complicated terminology. It may sound complicated, but it's not really hard in practice because a number of different libraries have been written that handle OpenID authentication. These libraries have been written by people and have been reviewed by plenty of people and used by plenty of people. So they're much more likely to be secure than any code you would write yourself. I would strongly urge you not to write your OpenID code by hand, not to write your OAuth code by hand. It's tricky, and there are people that have done it before you. So take advantage of that. All of these libraries will do vanilla OpenID, and some of them also handle Google Apps accounts. So now we've talked about identity. We've talked about how to figure out who that actor is, who the person is that is logging into the web application. But you want to know more than just who the person is. You also want to be able to integrate with their data. You want to be able to integrate with things like their calendar. Maybe you're a video mashup, and you want to integrate with things like YouTube. Well, that's what OAuth authorized data access is about. So in terminology, there's a protected resource. These are things like your calendar, your YouTube videos, and these protected resources reside on a server at Google. They require authorization to access, or at least to be able to edit at times. Some things are read-only, available publicly, but to edit them, you'll need to have access. And then there's the resource owner. The resource owner is the person or entity that owns a protected resource. They have the ability and the rights to grant access to that resource. Another couple terms we're going to talk about here is the client. In the case of the SASE payroll, online payroll application they'll be talking about, it's a relying party in OpenID terms. In the OAuth terms here, it's the client. It's the one that's making HTTP requests to the server, in this case Google Calendar, to access data. Fairly simple terms that you're probably already familiar with some of them. So the different Google servers that have protected resources, I actually just listed 8 of them on this slide, but there's actually even many more APIs than this. Google is really standing strong behind OAuth and strong behind OpenID as the standards that provide authorization and identity access. So most of our APIs are accessible by OAuth now, and there's a lot of different cool data. If you're into finance, you can get a user's stock portfolio. If you're into videos, like I said, you can use YouTube, but then there's all sorts of business applications as well. There are a couple more terms with OAuth that I'd like to talk about. There's key management. So the client needs to establish trust with the server. In order to do that, the client registers with the server. You're going to be seeing that shortly. And then there's access control. The server needs to decide when it receives a request from the client, whether it is going to grant access based off of the grants that have been given to that client. So let's talk about each of these steps. Step 1, the developer registers the client. That's the key management. Step 2, the resource owner, oftentimes a user, grants access to their data. That's access control. And then the client application actually does access the resource. In the registration step, I'm not going to talk about all of this, but basically there's a website that you go to register your application. Google has one for applications using Google consumer accounts. The Google Apps Marketplace, if you were here at that talk, has a special place that it gives you registration information. And then other companies each have this as well. So there's an example of the URL for Twitter to register your client. Here's what the web page looks like for the Google consumer sort of registration process. And I'm registering, this is that SASE payroll application. So I'm going in and I'm logged in as myself, as the developer, I should say here. And I prove that I own the SASEapp.com. There's a little bit of verification process that goes on there, either via DNS or via editing a file on your web server to prove that you own it. And then Google will issue a consumer key to you and a consumer secret. These consumer keys and secrets are basically used in OAuth to identify the client, and then also for the client to prove that its identity. The client has to be able to sign cryptographically the request to prove its identity. So you register your app, you describe the name of your app, and you get an OAuth consumer key and secret. We also support RSA stuff, but I'm not going to get into that in this presentation. But if you prefer using RSA instead of what's called HMAC, you can do that. So we've now registered the client. So the client has registered to the server knows who the client is. This is something you do when you start developing your application. You then need to have the resource owner grant access to their resources. Keep in mind the resource owner may not be an individual end user. It's basically the person who is authorized to grant access to those resources. And in the case of a company, it may actually be the company that is authorized to grant access. So your work email, you might not have the rights to be able to give an application access to your work email or your work calendar. Your company has to do that. And so we have 2 different types of OAuth that we'll talk about for those 2 different cases. So for the consumer, where the individual user is the resource owner, we use what's called 3-legged OAuth. 3-legged OAuth is actually the standard version of OAuth. If you see OAuth out there, they're likely referring to this. And what that means is that there is a series of web redirects where when the application needs to access the user's data, it redirects the user over to Google or over to Twitter or another provider and says, this application is trying to access this data. Do you as a user approve granting access to the data? In this case, I am the resource owner, and I'm at a company called Smart Law Firm. And the client is SASEapp.com. It's the payroll application that we keep referring to. And the protected resource is Google Calendar. I can choose either to grant or deny access to that resource here. Now, in the case of a business where the company actually owns the resource, they might want to be able to grant access to the SASE payroll application for all of their users' calendars in one step. For this, they can use two-legged OAuth. And the real difference here is that the IT administrator goes into their Google Apps control panel and actually says, this client, SASEapp.com, needs access to this scope, and that's a URL representing the calendar API. And they can authorize it on behalf of all their users. That way, when the individual user needs to have their calendar data integrated with the payroll application, they don't need to grant access, and they don't need to understand if they have the rights to grant access. They don't need to know if their security policies allow them to grant access, because the administrator can do it for them. So there are a couple different required elements when you're accessing a resource using OAuth. There's the consumer key and the consumer secret, which you already saw. You saw those were issued to our application at the time that we registered it. The consumer key is used to identify the application. The signature is created using the consumer secret and is used to prove that identity. And we'll show you an example of what that looks like here shortly. So when actually accessing the resources, the three-legged OAuth flow, where the user is individually approving access, requires an additional parameter called an OAuth token. That token indicates that the permission that was granted by the user. So it says that this application, SASE Payroll, has a right to access this user, Ryan's Google Calendar. So that's presented from the client to the server along with the rest of the request. In two-legged OAuth, however, because the access has been granted in advance by the administrator, that access is stored server-side. So all the client needs to do is identify itself and prove its identity using that consumer key and consumer secret and signing everything. And then it needs to say on whose behalf it is acting. So it is acting on behalf of a particular user within the organization. So in this case, it was acting on behalf of, let's say, Ryan at smartlawfirm.com. So it basically adds an additional query parameter saying who it's acting on behalf. And as long as the domain administrator has granted that access in advance, the client will be able to access that data. So here's what this looks like in an actual HTTP request. Just like with OpenID, there are libraries that do this for you, but I just thought you might want to see the HTTP request so you can understand what's going on here. So there's various things done in cryptography and nonce timestamp to ensure that this request isn't made again. And then there's also the signature, which is generated. So this is what it looks like. There are a couple different types of tokens with the three-legged OAuth scenario. So with the scenario where individual user is granting access via that website, authorize, deny, there are a couple different types of tokens. Basically, the application creates a request token, it gets it authorized by the user, and then exchanges that for what's called an access token. And I'm going to show this to you. Don't expect you to remember all of this, but there's an OAuth playground. It's a really helpful tool for learning some of this. It was actually written by another Googler here named Eric Beidelman. If you've seen him, thank him. It's a really awesome tool. So what it allows you to do is go to the top here, and you say, I am looking for access to a particular API. So I want to access to the contacts API. I click there. This generates what's called a scope, which is what data my application is trying to access. And then down here you can see there's an OAuth consumer key. We don't see a secret because the client in this case is actually this web application. It's the OAuth playground. So it has previously registered and gotten a secret, and that's stored on its server. So there's this three-step process here. I need to get a request token. So when I do that, it basically performs an HTTP request to the server, and the server returns a request token. It might be a little small, but I definitely encourage you to play around with it yourself. And then the next step is authorizing the request token. So hit authorize, and that does the redirect for me. And just the same, I can't understand Portuguese on this page either. But it does ask me here to grant access to my Google contacts. I recognize the words a little bit. And I will grant access. And then the application can exchange my request token for an access token now. And now it has everything it needs to make requests to an API. So what we're going to do here is actually retrieve my contacts. So once this is set up, you can access that API. And you can actually access multiple APIs at once. You can request access for calendar and YouTube all at one time. But I put the URL in here. This is kind of the URL to the REST API that I'm looking to get access to contacts. And I hit execute. And let me do a little syntax highlighting here. And you can actually see this says the title of this feed is Ryan Boyd's contacts. It retrieved all that information based off of this authorization header. It specified the OAuth consumer key and then the signature and passed that to the server. The server validated it. All right. So we've talked about getting access to the user's identity, knowing who the user is. We've talked about getting access to their data, figuring out, what their contacts are, what their calendar is, or what their YouTube videos are. But they've been multiple steps so far. You've seen me grant access to my identity, so to pass on my email address. Then you've seen me separately grant access to my contacts or my calendar. Well, we really want to be able to do this all in once. And so there's an OpenID and OAuth hybrid process, which combines these two types of requests. And it's a very simple three-step process again. The developer registers the client, just like it did with OAuth. The resource owner grants access to the data and access to the identity, and it all happens in one step. And then the client application accesses the resource. It actually occurs using a very similar process to OpenID, except as a result of OpenID, it returns an OAuth token. I don't dive into those details, but rest assured this makes it a lot easier for users and makes it less steps in the process. And you'll see this later with the SASE payroll application. So here is where, as a user, I'm granting access to both my identity, my name, and my email address, as well as my Google Calendar in one step. All right, so when do you use each of these protocols? Well, you may notice that the first two terms here I didn't talk about. I didn't talk about client login, and I didn't talk about auth sub. Although these terms are still pretty prevalent within our documentation, you don't want to use these for new applications, really, in my personal opinion. You want to use OAuth. You want to use the standards. So client login is where you pass a username and password and get access to the resources. For obvious reasons, you as an application don't want the liability of having a user's username and password. Auth sub was kind of the precursor at Google, the non-standard version of something like OAuth. So you want to use OAuth, and then there's the different flavors that you can use. Three-legged OAuth is where you redirect the user in the browser and ask for access to their data. You use that when the individual user owns the data. Two-legged OAuth is when you want to access data for an entire organization, for entire Google Apps domain in the Google use case. OpenID is when you want to access a user's identity, and then you'll note that there's a special version of OpenID for Google Apps. And then lastly, there's the OpenID and OAuth hybrid that allows you to combine these things together and do it all in one step. So now I want to kind of take all of this information that you've learned and talk about an integrated application and how it evolved. So this is the SASE payroll application that I was talking about. The SASE payroll application launched a long time ago, and just like every other application on the web, it had email addresses and passwords. For every user within the system, it stored both those email addresses and passwords in a database table that looks like this. So the bottom part of the screen here I'm going to use to show what the database table looks like. And here's a quick video showing what that looks like from a user experience. So the user says they don't have an account, they're going to create one. They log in. They enter their email address, they specify a password, a very short one at that. They then get an email, and they're asked to confirm their account. They click on that confirmation link, and then they have access to their payroll data. Now, that was a very quick recording of the video, but oftentimes for many users, it takes a lot longer for them to perform those steps. So the SASE payroll application wasn't integrated with anything when it first launched. It was just a payroll application. But then Google in 2006 launched the Calendar API. The Calendar API was the first of our Google Data APIs based off of the Atom Publishing Protocol. And it allowed the SASE payroll application to add events to a user's calendar to indicate when the user was getting paid. So it's very helpful if you have an upcoming mortgage payment or car payment to know when you're getting paid. So you want to be able to look at your Google Calendar and have that information. Because Google Calendar launched their API, SASE payroll was able to offer that service to their users. But the first version of the authorization protocol that Google made available for this was auth. And auth was this proprietary protocol, but it looked much the same as OAuth does today to the user. So the user table in the database has increased a little bit. In addition to having the email address and the password for the user, it also has a token for the user. That token represents the application's access to the protected resource, the application's access to Google Calendar. So let's see what that looks like. So here, below my payroll dates, I have a link that says add dates to your Google Calendar. And the video is freezing here a little bit, but hopefully, yep, it'll continue. So I click add dates to your Google Calendar. Then I'm asked to grant access to my Google Calendar, just as you saw with OAuth earlier. I grant access. The application now says that dates are being added to my calendar. So I go into my Google Calendar, and I can actually see that the pay days have been added to my calendar. So you can see for May 15th and all the other days in the month, here the pay days were added. Very useful for me as a user to know when I get paid. So I'm very much happier with this application and will continue to use this payroll application for my small business. So then the users kept on complaining. You've made it really easy for me to integrate with my calendar, but why do I need to create another username and password every time I access my payroll? Why do I need to keep logging in? And so with launching OpenID in 2009, Google made it easy for the SASE payroll application to actually log users in with their existing Google accounts. So you can see here now this application database table, or the user's database table, no longer needs to have a password for the user. Instead, it just stores the OpenID. And this OpenID just represents that user, and it's validated with Google. So if the user visits again, it gets, Google passes on, asserts the OpenID, and the application can look it up in the database table just as it would look up a password. And now you can see how the experience has improved by implementing OpenID in the SASE payroll application. So instead of entering my username and password, I just type in my email address here and click login. I click allow because I'm already actually logged in. I've already typed my password to Google, and I'm instantly signed in. I no longer need to provide a new password, which oftentimes won't be a new password. And I no longer need to deal with any of that email confirmation because the SASE payroll application is trusting OpenID. And then the process of granting access to calendar is just the same as it was before. But there's two steps there, you'll note. So then at the end of 2009, Google launched this hybrid OpenID and OAuth, which we saw. And what this meant is that they could do these two steps in one. However, we're now using OAuth for authorization, the standard, instead of using this auth proprietary protocol. It's a step forward for this application. There's a little more code to write, but their database table also has to store what the token types are that the application is using. So you can see some of these tokens were auth subtokens, and then the third token is an OAuth token. And with OAuth, there's also this secret, which we haven't gotten into much, but it needs to store that secret. And here's how that experience has improved for the users. Okay, it's the end of the day here. Is everyone getting onto the internet maybe? Oh, there we go. Okay, so again, I type in my email address, and I hit login. And then you can see it asks for access to my email address and my Google Calendar in one step. This just makes it a lot easier for the user and makes it better for the application because the application has gotten its new users faster and thus will get more new users. So it's granted in one step. We're not going to finish the video here because we're running a little bit late on time. But the next step here is Google launched the Google Apps Marketplace earlier this year. Now, like I said, this isn't really a talk on Google Apps, but it does show an evolution in how OpenID and OAuth have made things easier for users. With the Google Apps Marketplace, an IT administrator can add an application like SASE Payroll for all of the users within their organization at once. That's why you see here 3 rows were added to my database table. And none of those rows have a token. They all say two-legged OAuth. And what that means is that the SASE Payroll application can access all of those users' data just by proving its identity with its consumer key and secret. It doesn't need tokens granted by each of those users because the administrator has granted access to all of them in one process. So let's show this, and this is kind of the final video here of how OpenID and OAuth have evolved for the SASE Payroll application. Maybe. Come on, this is the best one. All right. So we're in the Apps Marketplace, which is a store for web applications. I'm an IT administrator in this case, and I'm signing in. I'm entering my Google Apps domain name. And after I enter my Google Apps domain name, I click Go. Maybe? All right. Hit Go. All right. We'll wait a second here and see if this picks up. Otherwise, I'll just talk through it a little bit. But all right. So there's a very simple install process. This simple install process first has me agreeing that I love the SASE Payroll application. It's agreeing to the terms of service. Then the next step is granting that data access. So here, when you see it, the IT administrator is going to be granting access to the data for the entire organization at once. So it's saying it's okay for this application, the SASE Payroll application, to have access to all my users' Google Calendars. I'm going to grant that access. I trust this application. And I used a non-SSL URL, so I'm also saying I don't believe in security in one step, but we'll ignore that. You want to use SSL for accessing our APIs, even if some of the APIs work without it. So then I hit Grant Data Access. And enable the application. The SASE Payroll service has now been installed for all of my users and enabled. So users can go to their email and go to what we call the universal navigation bar, which is that navigation at the top left here. And they can click on the SASE Payroll application. I promise it really does work faster than this in real life. Once they click on the SASE Payroll application, the user is actually immediately signed in to SASE Payroll. Because the administrator had installed this application and granted access for all the users in the organization, the user doesn't need to OK passing its identity. The dates are also already being added to Google Calendar. So every user has their payroll dates on their calendar, even though they didn't individually interact with the SASE Payroll application. I don't know about you, but most people don't visit the payroll application on a daily basis. So this is great. They're getting access to when they're getting paid, and that's the information they need. So the future of these protocols, like I said, it's really kind of crazy in the standards bodies. There's a lot of things being discussed. There's a new version of OAuth that's in draft called OAuth 2.0. It basically tries to make it a lot easier for application developers by eliminating a lot of the cryptographic signing of these requests. That's the most complex part of this. But there's not 100% agreement on it. Actually, one of the primary authors of the draft has a blog post basically saying making it easier isn't necessarily making it more secure. And so I encourage you all to read up on that. His blog is actually in the resources section, which I'll show here shortly. So OAuth 2.0 also does some things around making sure OAuth is compatible with mobile devices and desktop applications, and that's all documented in the spec. You could do some of that stuff with the previous version of OAuth, but it wasn't explicitly documented. There's another project underway called OpenID Connect, and the idea behind this is why not pass the identity information to an application by building on top of the existing authorization protocol. So building on top of OAuth 2 to allow the user to grant access to passing their identity. Have one protocol instead of two. I'm very supportive of this, but we'll see how this works out in the standards committee. There's a lot of active discussion. There's a lot of passionate people in this space. So here are some resources. We have technical docs on OpenID and OAuth. There's the OAuth Playground tool that I talked about. And then lastly, there's the blog by one of the very prominent authors of the OAuth spec with a lot of debate on it. So I would encourage you all to read that if you're really interested in these protocols. Thank you very much.